Okay, so in lesson number 2, we learned how to determine the measure of an angle given a trig ratio for the angle. For review, complete the following. We are not going to do that. I just reviewed that with you. Go ahead, Isaiah, tell me how you would find x. Real quick. What do you use calculator?
What?
With your calculator, how would you find the measure of angle x?
So you get
Second function sine, and you get type in 0.45. Now, what do you have to make sure about in this chapter? I had a girl do the entire test in the wrong mode. She couldn't figure out why she was getting all the multiple choice, wasn't making any sense, and then she's like, I think I'm in the wrong mode. I'm like, yes, you are. Yeah, you have to be in degree mode. Okay, so make sure your mode is in degrees. It should be still there. Before every test, I would check. Okay, just to be sure. All right, so let's go here. Let's just go right to the class example. It says, in each case, calculate the measure of the indicated angle to the nearest degree. Okay, so this isn't too bad. This is exactly the same process as we did yesterday. What do we have? What do we need? How do I get there? Right? You always, whenever you face a problem, think about what you have first, think about what you need to do, and then how you're gonna get there. So from the angle, I would label the sides just like we did yesterday. Relative to the angle A, this is the opposite, and this is the hypotenuse. And so now you know what to use. What trig function will you use, Logan? Yeah, sine. What will you put after the trig function? Oh, and what do you put after the trig function? Help them out, Mia. Do you know what you always put after the trig function when you put the angle? Yes, always put the angle after the trig function, and then you put down the two sides, which is opposite over hypotenuse. This is exactly what we did over there 30 seconds ago. So now to finish, you will go second function sine of 4 over 6, hit enter, and your calculator will give you the degrees that angle is. What do we get? Let's go, what is it? What do you get, Evan?
42.
42, nearest whole angle? Somebody agree?
Yeah.
Okay, good, next. What do you have? What do you want? What do you need? How are you gonna get there, right? So you look at this little angle. Oh, there is a McDonald's commercial from years ago. I don't even have a TV anymore, so I don't have it. But it is the funniest thing in the entire world. It's about when they have hockey cards. And so they're, promoting their hockey card little things, these hockey cards, whatever. And so this old guy, shouldn't say old guy, a guy with his son comes in and he's totally bald. And they sit down at the table beside another gentleman who's not bald. And they're talking about their hockey cards, and then they're like, well, what do you have? And the guy goes, well, what do you want? And then it advertises the hockey cards and something, and then he comes back, and the guy that had hair is now bald, and the other guy has his toupee. It is so funny, and he's got the hockey cards. So they traded the hair for the hockey cards. It's great. So every time I think of what do you have, what do you want, what do you need, I just think of that commercial, and it's so funny. Okay, so what do you have, what do you want, what do you need, what are you going to do? So this is the hypotenuse, label your sides. This is the adjacent relative to angle B. And now you know what to use because those are the only two words you see. So you use what, Hannah?
Cosine.
Cosine of what?
B.
The angle B, which is the adjacent over the hypotenuse. Second function cosine, type in your sides, get angle B. Angelina, what'd you get? To the nearest whole degree.
58.
58, someone confirm? Okay, we should put little degrees on those, by the way. Little degrees. That's like saying centimeters or whatever, right? You need to have a little symbol for degrees. Okay, letter C, same thing. The deal is, what do you have? Everything. So we have the opposite, the hypotenuse, and the adjacent. You can pick whatever you want. It does not matter what you use. They will all give you the same answer for C. Isn't that really cool? It's so fun. So pick it. Sine. So sine of C, always put the angle after the trig function. And that's going to equal the opposite over the hypotenuse. Do the math, you find C. Okay, moving on. We all good? Exactly the same as yesterday, just one little thing different. Okay, now, next lesson part. Right here, here is something that you need to know by definition. They're about to tell you, they're going to give you a scenario. They're going to say, there's a sunken ship. Oh, my word, I just do that. I think I did. They're going to tell you about a sunken ship, and they're going to talk about a helicopter, and he can see the ship sunken at an angle of depression of this much, and the guy at the boat, he can see the helicopter at an angle of elevation of this much, and you have to draw the picture. So what is super important to understand is that when you draw this picture, which angle is actually elevation and depression. So the angle of elevation, according to this, is measured upwards from the horizontal. Stick your hand out. Horizontal. Everybody do it. Horizontal. Okay, now, imagine this line that you just put your hand out, just like you have like powers, and just goes whoosh, and you now have like a net from your, because you're Spider-Man, and there is a line now. That's right. Put it over there. Okay, that's now been drawn. Okay, that is in the atmosphere. You're drawn. Now, if you're going to go angle of elevation, you're going to go from that line, and you're going to go up. So your armpit that you just made there, that is from your line, to up. That is now the angle of elevation. The elevator takes you where? Why do we have elevators in buildings? To take you up. Now they also break you down, but we're going to talk about to elevate someone is when we elevate God, when we want him on his highest throne, we put him up there, right? So elevate means to go up. Are you okay with that? Elevate means up, yes? So from the horizon, put your web out there, and we're going to go up. That angle that you just made was elevation. Okay, now depression is just what you think. If you're depressed, we talk about you're being down in the depths. You poor soul. So there's your angle, there's your horizontal, and you drop down. What you just created there is your angle of depression. Isn't that great? Fantastic. Okay, so from the boat, there's a little picture. We have a helicopter and we have a boat. Now, you can argue, but Mrs. Sewell, where's the little guy? He's like in front of the boat, like he's getting pushed by the tugboat. He's dying, he's swimming, and he can't. I don't know, but let's just pretend. Okay, so the angle of elevation of the helicopter from the boat, here's his dotted line, and when you go up, don't you wish your finger had powers like mine? And then that's your angle of elevation. But the angle of depression from the helicopter to the boat, the helicopter, see the horizontal line? This is the angle of depression. So when you draw them both, if you draw the horizontal from the boat up to the helicopter, and you draw the helicopter down to the boat, guess what those things happen to be? Do you see the Z? Do you see the Z? Come on, tell me you see the Z. See the armpits of the Z's? See it? Oh, they're the same thing. But let me tell you where the angle of depression is not. Ready? This is what everybody does. They draw this blue triangle, and then they say the angle of depression from the boat, or from the helicopter to the boat, and guess where they draw it? Right here. Like, no, failure, right there, ding, fail. Okay, that is not where you draw the angle of depression. The angle of depression is from the horizontal, stick your hand out, and go down. So here's where sticking our little hand out right there, and we're going down. That is the angle of depression. Do you understand? Always from the horizontal. Okay, here we go. A tree, 5.1 meters tall, casts a shadow. Oh, this is a good question. Where are shadows? On the ground. Yeah. I think it's so great. Now, it is possible. Okay, Shadows aren't always on the ground. It is true that if you stood beside a building and the sun was here, there would be a shadow that would kind of be on the building. So I get it. But the tree, the shadow of the tree in the field, the shadow is going to be on the ground. Just in case anybody needs to know that. Shadows are on the ground. So a tree 5.1 meter casts a shadow. So if this is the tree and this is my shadow, the sun is over here. You know, in the corner of your page, like when you were little and you drew the sunshine like this. Did you do that? Tell me that you did that. On the corner of your page, you didn't draw, and then you drew the birds like this. You know, come on. Did you draw birds like that in your page? You still draw birds like that. Okay, here we go. The question is, calculate the angle of elevation of the sun to the nearest tenth of a degree. Elevation is always from the horizontal, so go find your horizontal line, which is right here, and that's the angle of elevation to the sun. Always from the horizontal. Okay, here's what we know. This is 5.1, the tree. The shadow is 7.5. We're trying to find that angle. How big is that angle? A little space there. So you label what you have and you wonder what you need. This is your opposite. This is your adjacent. So now we're going to use what? TOA. Tangent. Tangent of what? A. Tangent of A. It's always the angle there. I mean, I say that over and over and over again because I've been teaching this a long time. Okay, well, not that long, but a little while. I've been teaching this class, and I know where kids make mistakes, and that's one of them. They don't know what to put after the tangent. Always put the angle, then your equal sign, then your opposite over your adjacent. Now, grab your calculator and get to work. Okay? Final answer? To the nearest tenth of a degree, please. Quick. Go to what to go right. 34.2. And this is degrees, so put a degree symbol on it. Turn the page. First of all, I should say, any questions about how did I do this? How to know how to label the sides? Nothing? Okay. A boat is 130 meters from the base of a cliff. Become a good artist. My skills have really improved over the years. There's my cliff. The boat is 130 meters from the base of the cliff. The cliff is 80 meters high. Draw a diagram to represent this scenario and mark the angle of depression of the boat from the top of the cliff. So from the top of the cliff, pretend you're up there and you're sticking your arm out and you're setting your web out like that. And the angle of depression, of course, would it be the X angle or the Y angle? Is it the X angle or the Y angle that I just drew up there? Look. X. Are you sure? Logan, is it the X or the Y? Are you sure? Yes. Yes, he's correct. So angle X, that's the angle of depression. It's always from the horizontal down. Okay. Determine to the nearest angle, degree, the angle of depression of the boat from the top of the cliff. I need to find that angle of depression. Now, I can do two things. At this moment, I could draw this triangle over here. So this would be 130, and this would be 80. You following me? And now you have a triangle with X in it. The other option is, of course, is to draw your little X down here in this little boat corner, right? This little X could go here if you wanted, or you can just redraw it around the X. It's the same exact thing. We're talking about the opposite and the adjacent. You're going to use tangent. Opposite is 80. Adjacent is 130. Throw it in. Find the angle of depression. You good? Make sense? Okay. Anybody find the answer for me? Hannah, did you? No. 32 degrees to the nearest angle. Was it an angle? So X is 32 degrees. Okay, good. Here's an isosceles triangle. Let's consider that. KL is 20, right below. LM is 20, and K to M is 30. Okay, you do not have a right triangle in that scenario right now. We cannot use subtotal because where's your hypotenuse? We don't know. The hypotenuse has to be across from 90 degrees. If I don't have a 90, I don't have a hypotenuse. Do you understand that? Okay. So, we can't use it. Why can't we? There is no right angle, which implies there is no hypotenuse. Okay. So, let's make one. We can do that. So you take your pen or your pencil and you draw a line straight down. Now you are able, because it's an isosceles triangle, this works, okay? When you draw that isosceles, that line down.
Sorry for the interruption. I did miss one announcement this morning for the Junior A girls basketball team. The game in Sundre today is canceled. So I think that information was sent out, but if it was not, or if you missed it, there is no game in Sundre today.
I'm making 90 degrees, and because this is an isosceles, and only because it's an isosceles, now get this and listen, okay? Because it's an isosceles, when you draw that 90 down, it cuts this into 2 equal parts, okay? If that was not an isosceles, it would not cut that line in half, all right? But because it is an isosceles, it does. All right, they're both 15. Now we can go find the measure of angle KLM. We are supposed to find the measure of angle KLM. Go from K to L to M and find this. Well, we can't find the whole thing yet. Well, how about we find half of it and double it? Yeah? So let's find this. I'm going to put an X there. Let's go find angle X. What are the 2 sides that we have? Hypotenuse here. And this one is opposite of angle X. So that tells me to use sine of X is equal to opposite over hypotenuse. Find it, double it, and that's your measure of KLM. Yeah? Did you get 48.59 something or other for the first one? Okay, now careful here. Hold on. When you get X to be 48.59 do not round that to 46 to 49. Sorry. Don't round it yet. Times it by 2, right? And what do you end up with? Well, when you times it by 2, you get to the nearest degree is how much? 97 degrees. So just be careful not to round. Don't round until the end, okay? You listening to me? Don't round until the end. Keep it on your calculator and just go times 2 and get your 97 and then round. Okay, because they'll be a little bit finicky. All right, I'm done. Any questions? What do you need? What do you have? How do I get there? Okay. I've tried to find that commercial. I can't. I've YouTubed it. I can't find it. It's obviously better than what I said because